When we're talking about natural versus artificial light, there is three main things we need to cover. The wavelength of light, which is what we just talked about, the color temperature of light, and then the brightness of light. So when we're talking about the wavelengths of light, we have sunlight on the left and your typical screen, MacBook on the right. You could see that the sunlight has UV light, it has blue balanced by red and infrared light. The MacBook has zero UV light, so you're not getting those UV benefits. It has a huge spike in blue light and little or no infrared light to balance it out. So when we're exposed to only this MacBook spectrum of light, we're getting that blue light damage that we talked about earlier. The color temperature of light is basically how warm or how cool the color looks. In the morning, during the sunrise or sunset, you have golden hour where everything looks warm, everything looks golden. In the middle of the day, the color temperature is the highest, and this is when things look kind of icy. They look very cold. And then brightness, this is super important. It is around 10 to 100 times brighter outdoors than it is indoors. You want dark nights and bright days. So we're spending 90% of our time indoors and essentially reversing that process. Brightness is measured by lux, and you can see that your office lighting is 300 to 500 lux, and outdoors it could be anywhere from 10,000 to 100,000 lux. And bright light itself is a stressor, no matter the frequency. If the light is bright, it will stimulate your brain to start making hormones. It'll tell your brain that it's daytime. And the more bright light you get during the day, the more protected you are from light at night. So what are those natural disruptors of light that we talked about? The first one we mentioned was windows. Glass will turn your full spectrum sunlight into artificial light. It completely blocks that UVB, which we had the vitamin D and POMC benefits. It partially blocks that UVA, so we have less nitric oxide. It has zero effect on blue light, so that blue light is staying at 100% intensity, but it blocks 30 to 60% of red light and infrared light. So now we're getting that same sort of peak we had in that MacBook. And we've all probably seen this image going around as almost a sunscreen ad. And this is a truck driver, but what you don't realize is truck drivers, their side window is usually up and the opposite window is down, because this keeps air ventilating, but it also isn't as loud as having the wind by your ear all the time. So the left side of this truck driver's face was exposed to that blue light, that UVA light, and took away that red and infrared light frequencies, and you could see this caused a lot of excessive aging. And modern life is indoors. We're spending 90% of our time indoors. So what are the actionable steps for you to do right now? The first is you want to be in a room with a bunch of windows for that lux, that brightness. Then you want to open as many doors and windows as possible to get that full spectrum sunlight. The second thing you want to do is take regular sun breaks. I'm going to mention the most optimal times to take sun breaks in a little bit. The third thing you want to do is work outside as much as possible. Now, this isn't an option for everybody, so do what you can. Next thing that turns full spectrum sunlight into artificial light is sunglasses. Remember, our most powerful sensors are in our eyes, and sunglasses block UV and other wavelengths of light. So when we're blocking these wavelengths of light, we're interrupting the signal from our environment to our brain, and we're creating less of those POMC cleavage products like alpha MSH, which creates melanin. It reduces your appetite. And when we're wearing sunglasses, since we're not making as much melanin because we blocked that signal off, we are way more susceptible to burning.